Okay guys, so here is how this tumbler works. There are 3 tumblers right now running. If you look at this one, it's still making a lot of noise. But you could hear the lapis grinding in the first one. And the second one, the lapis is going to the second stage. And in this one, actually I'm waiting for mine. One of the drum which had some problem, so hopefully it's gonna be back. And this is the third tumbler which is running. Let me show you closely. So this one is going through polishing, and if you can hear the peridot noise, yes you can. Pretty much mostly running inside getting polished. This is the machine. And this is the whole assembly. If you can look at it, I don't know if I can zoom in, but if you look at this one, this is the motor which is turning this shaft, which is connected to the other free running shaft, and that's how it's making the rotation. And then there's this black tire you see, and everything has been nailed to the concrete. So there's less and less. See, like the friction which I was talking to you about, pretty much touching this thing for setting fly. And this is a boat which I wanted to also show you, because it's a heavy tumbler, so I made this kind of a ramp which is movable, and I can move this ramp and put the drum over it and then roll it down, and then they clean it over here. There are some of the bins which I showed you earlier. So anyway, I'm leaving for United States today. Okay guys, so this is the tumbling unit I made. Actually I made 4 of them. As you can see, this is the first one. I want to go into its mechanics first before telling you the whole story how I came up with it. Okay, basically it's a very simple mechanical engineering as per se. There is a 1/2 horsepower motor, and let me squeeze in so you can read if it focuses well. Okay, here you can see the motor specs. It's 1/2 horsepower motor with 1460 rounds per minute and 50 hertz. I think these are the major specs you will probably need if you're making one for such a huge tumbler. And if you can see, it has been connected through I believe it's a 4.5 inch pulley to a shaft, and shaft has been connected, or there are like 2 shafts. One, there's a bearing in there, and shaft goes through the bearing. This is called the bracket, and this is the bearing, and this is the iron shaft. And we have, it's hard for you to see, but I had done to local people some lathe work on it to make the iron, which was I believe 2 inches or something, and made it into fit exactly into this bearing. I don't know if I can zoom in and see the bearing. So this is one shaft, and then this is the other, and the drum sits on top of it. And in case you're wondering what's this, the crude way of making sure the drum does not slide toward the motor or toward the bearing. So what I did was I had my ironsmith to weld an aluminum pipe, and if you can see over here, it is making some scratches. So this drum, let me first show you, before even going into the drum, let me show you how it looks over here. So basically this is the shaft which is rotated through this motor, and then I've connected this shaft to another shaft, which is this one, through a belt. And I believe these are 1-inch pulleys, and the same procedure. So if you look at it, it's the iron, and I've done some lathe work on it and applied a tool, not me but my lathe guy, and it fits right into this bearing. So basically, oh yeah, and then the stand which you see up here is approximately 4 to 6 inches tall. I believe it's 6 inches, and I had put some nails in the concrete, and I have welded the stand over this concrete. So pretty much very crude way. If you look at this barrel, which took me actually longer time, and it went through a lot of iteration. Initially, when I built this barrel, actually not me, but the ironsmith I had available, we did actually 3 feet long and 1.5 feet in diameter. So this, let me see if I can zoom in. This diameter was 1.5 foot, and the length from one corner to the other was 3 feet initially, but then, and the stand used to be like 3 feet tall, but it miserably failed. And one of the reasons it failed was also because if you look at closely, there were no tiles at that time. So it used to had just this plate which he had welded, and it used to make tremendous noise. So first of all, what I did was I cut the stand to 6 inches only, so there are no movement on the stand. Secondly, I got an idea. There are some local workmen available who do horse carts. So like they make tires for horses, like these carts which are run by horses. So pretty much they have done the same thing here. And let me see if I can zoom in for you. So basically, this is the plate which was earlier there, welded onto the drum, and then this is what the horsemith did. Sorry, my hands are all dirty now. And this is the rubber, and now it doesn't make that much noise that it used to make, plus it rotates smoothly. Currently it is rotating about 30 to 35 rounds per minute. So basically what I did was, let me show you the second stand, because when I was after making this one, I actually made four stands, because our tumbling process usually involves 4 cycles. Like the first one, which I'll explain later, is usually 80 grit or coarse grain silicon carbide. Second is relatively less coarser, which is 180 grit, and then third is usually 600. So basically the stand, so this one was our first, like 80 grit coarser grain. This one which you see has been running for the 180 grit, and there's a separate drum for it, and the third one is supposed to be for 600 grit, and the fourth one is for the polish, final polish. So currently, thanks to Pakistan Energy Commission, there is no electricity. But anyway, let me show you. I also had to do some electric wiring work for these machines. So basically, you see these 4 machines have a separate switch, and So here is the fuse, and these wires run all the way to the motor. The second stage and the third stage motors got busted, so my mechanic fixed it and they're putting it back on. So I've been running this for almost a month now. Let me show you what I did so far. Currently there is the capacity so far which I'm running on this huge barrel is close to 100 pounds, 50 kilograms, around 110 pounds. And in that barrel, which is at the last stage right now, we have peridot going through the final polishing stage. And if you see here, this is the lapis, around 100 pounds of it. So basically, this is how the lapis is poured in and into the barrel. Since this is a barrel which is usually run for the coarser grain, which is 80 grit, so we don't have to clean the barrel all the time because this barrel is only used for the first stage. So show you the lapis again. So it went through this stage for 7 days. I'll show you. This is what these are some of the stuff, and I have to take it out from the. So this is the lapis which came out after 7 days, and sorry, it's poured into fresh water, not the water from the barrel, but lapis still have, see, there's some breakage, which is not good. But if you look at this lapis up here, it was pretty much very hard to tumble, but it has gone through this first stage. So if you see, this has some rounded corners. Let's see, which one is this? So if you can see there, it has rounded it off. So let's compare this lapis piece. This one seems perfect tumble. So let's compare this one to what it used to be. So this is kind of what it was before, and this is what I got after tumbling. And it has only gone through the coarser grit. So after 7 days, this one will be poured into now 180 grit. So let me show you how smooth it is when it is wet, but when it gets a little dry, it's not as smooth, I believe. But let me show you. This is what the 80 grit tumbling process for 7 days did.